Dispersion of light. You would have seen that when we focus a wide narrow beam of light on a prism inside a dark room, it gets split into 7 beautiful colors like that of the rainbow. VIBGYOR or Vibgyor. This phenomenon is what we call dispersion of light. Now, what explains this? Here, you can see that the red light has the minimum angle of deviation compared to all the other colors, while violet has a maximum. And also, according to Fermat's principle, light ray always chooses the path of least time. But here, the light has chosen many different paths. Does this mean that A, the refractive index of the prism is different for different colors, and B, is the speed of each color of light different? Can we explain this phenomenon using just the ray diagrams like we had used to find the refractive index of prism? Well, no. There is something else working here. You must have heard about the wave theory of light. According to this, light is an electromagnetic wave, and white light in particular is a collection of waves with different wavelengths. So, how does this wave theory explain this dispersion? You see, each color here is a different wave of light. In vacuum, the speed of light is constant for all these different waves or colors, but it depends on wavelength when it passes through different mediums. So, speed is dependent on wavelength. Again, we know that refractive index was nothing but the ratio of speeds in vacuum and in medium. Therefore, refractive index depends on speed, which is dependent on wavelength. Thus, refractive index depends on wavelength. Thus, when white light consisting of all these waves passes through a medium, each wave or color selects its least time path based on its refractive index. And we thus get refraction of light colors to different extents. And thus, we get refraction of different colors to different extents. Also, from the image, it is obvious that red light has the lowest deviation. Therefore, it has a least refractive index. But red has the maximum wavelength among all the 7 colors of Vibgyor. Therefore, refractive index is inversely proportional to wavelengths. Now, let me ask you this. Instead of white light, which was a collection of different colors, what if we choose just one color? Does it also, like the white light, get split into different colors? Well, no, because any medium can't change the frequency of any wave. Frequency is a number of waves that start from the source of light per second. Since this frequency doesn't change, the color of light remains constant throughout. In fact, V is equal to mu lambda is the equation which explains all this, where V is the speed, mu is the frequency, and lambda is wavelength. Since we know that frequency does not change across mediums, but wavelength does change, the speed of the light should also proportionally change with lambda. Thus, speed of the wave increases with increasing lambda and vice versa. So friends, in this video we discussed about dispersion of light, how it happens and how it is dependent on velocity and wavelength. Till next time, happy learning.